Hello and welcome back to the second class of class 6. We left off, we have been learning about basic geometrical ideas, which is chapter 4. We finished off with the first exercise. Now let's search deeper inside and learn about a few more basic concepts or topics. All right. The next topic that we are going to learn regarding basic geometrical ideas is curve. Now, many of you may be wondering, curve, we know this. Curve, we know this. We have been learning about all this. But not only these, but there are more than this, okay? Any drawing you do, anything you draw, all these are called curves. In short, you can even call this as doodling, right? Sometimes you sit idly and you draw anything you feel like on your notebook. All these are called curves. Now, when you talk about curves, there's another small fact, a small term, which we call as simple curve. Now, before we go here, let me draw two curves here. Now, even without me explaining about this, you will easily be able to identify which is a simple curve, right? Obviously, this is a simple curve. So, why this is called a simple curve is because this curve has no intersecting points. They are not crossing over anywhere. Whereas, in the second curve, this curve, they are intersecting in so many different ways, so many different points. So, a simple curve means you start somewhere, go around simply and come back without touching each other. So a simple curve means something like this. It can be something like this. All right, it can be like this. They have to touch each other, of course. All right, now these are called simple curves. Now when you talk about curves again, there are another two terms where we will discuss. The first one is closed curve. The second one is open curve. As the name suggests, closed curve means it should be closed on all sides. Closed curve. All the sides are closed. All right. Open curve, as the name suggests again, open. This side is open. All right. Any figure that has an opening, this is open. So these are open curves and closed curves. So this is all about curves. We will further talk about curves later on in the exercises. So let's move on to the next topic. The next topic is polygon. We have already learned about curves. Now, polygon, its definition is a simple closed curve only made up of line segments. Now we have learned about closed curves, we have learned about line segments. So this means if you draw a circle, this is not a polygon because even though it is a closed curve, it is not made up of lines. This circle is not line, right? It's not a straight line. So any closed curve made up of only line segments are called polygons. So the least number of sides a polygon can have is 3. This is a square, a rectangle, all right? You can draw any shape. As long as they are closed and they are formed by line segments, they are called polygons. Now when you look at these polygons, there are 3 things that you have to know. First is, a polygon has sides. Here we have 4 sides. Here we have 3 sides. Here again 4. Here also we have 4. Now polygon may have a number of sides, okay? It may be of 5 sides, 1, 2, 3, 4, 5, 6, 7, 8, different number of sides. The next thing that you have to know is about vertices. In plural it is vertices, singular it is vertex. It means a point where 2 lines meet. They are meeting here. Here, they are meeting here. These two lines are meeting at this point. These two lines are meeting at this point. These are called vertices. Let me name them A, B, C, D. So you can see that this is a vertex for singular, vertex A, vertex B, vertex C, vertex C. Or all together, vertices A, B, and C, C and D. All right? These are the things that you have to know about polygons. And there's one more thing. The third thing is diagonals. When two opposite points are joined by a line, these are called diagonals. So A, C are opposite points, so you connect them, join them together, it forms a diagonal. Similarly here, diagonal. I hope you are getting this. So when you join two opposite points, they are called diagonals. All right? So this is all about diagonals, polygons. Let's move on to the next topic. The next topic that we're going to learn about is angle. Angles are formed by two rays. We have already learned about rays which share a common point. That means we have a common point O. Let's say it's O. Now from O there is one ray going up, one ray going like this. Let's mark this ray as OA and this ray be OB. Now, angle is formed when a corner is formed here between two rays. So the corner formed the corner formed in between ray OA and OB is called an angle. So this part is called your angle. I hope this is clear. Now, these rays, they have names, certain names for it. These two rays, OA, can be called arms or sides. OA can also be called arms or sides. Similarly, OB can also be called arms or sides. All right? OB can also be called arms or sides. Now, we have already learned this point where two lines meet, okay, or two rays are meeting. This point is called a vertex, since it is only one singular for vertex, or vertices is vertex, all right? Now, this angle also have a property where this angle has an interior part and an exterior part. So we already know what interior is. Interior means inside, exterior means outside. Now, which is the interior? Interior means the space bounded by two lines, these two rays, sorry. Now, we already know that rays extend, okay? They extend. So, the interior of the angle will be all this, as long as the angle extends, the rays extend, sorry. All right? So, these are your interiors. It is not restricted. It cannot be stopped. The interior means it will go on. It is very vast. All right? Similarly, the exterior, the remaining portion, this portion, the outside, these are all called exterior. Okay? So this is all about the curve, polygon, and angles. Let's do some exercises to get further understanding. So please turn to exercise 4.2. Exercise 4.2. Now, if you look at exercise 4.2, they are asking us question number 1. Exercise 4.2, question number 1. Classify the following curves as open or closed. All right? Now, the first question is open. If you look at the figures, you can understand which is open. The ends. Let me show it to you. In the first figure A, it is Z. Both sides are open. So this is an open figure. When you look at B, all the sides are closed. So this is not open. C. If you look at C, there's a small opening here. So these are called open curves. So we will just mark it as A and B. When you look at the next question, closed, the remaining three are closed because they have no opening. So we can write, closed B, C, sorry. This is C, not B. B, D, and E. They are all closed, right? When you look at the next question, question number 2, they are asking us to draw rough diagrams to illustrate the following. One is open curve, the next is closed curve. So A, you are supposed to draw rough figures of open curves. So we already know what open curves are. Leave a gap when you draw a curve. Leave a gap when you draw a curve. Even with straight lines. See, in mathematics, we can say that a straight line is also a curve, okay? When you use straight lines. We generally think that curves should be bent like this. But all these are curves, all right? So these are some examples. Similarly, for closed, now you make sure that there's no opening. You draw anything, make sure that there is no opening. For example, a square, right? These are the different examples of open and closed. Now let's look at the next question. Question number 3. Question number 3. They are asking us to draw any polygon. So polygon is made up of line segments. Let's take a square. So they're asking us draw any polygon and shade its interior. So simple. Interior means inside. So we'll just mark it A, B, C, D. So this is a polygon. You're supposed to shade the inside. Inside, interior means the inside. So with this is we get the answer for question number 3. Now, all right. Now with this, we will move on to question number 4. I'll just read it out. Consider the given figure and answer the questions. So they have given us a figure, a star-shaped figure in your textbook. Now they are asking us, A, is it a curve? Question number 4A. Is it a curve? Yes, it looks a little complex, but it is a curve. All right? And B, is it closed? Yes, obviously, there's no opening, right? So, again, you write, yes, it is closed. All right? So, with this, we are done with the exercise 4.2. Let's move on to exercise 4.3. Exercise 4.3. So, in this exercise, we'll be dealing with angles. The first question, name the angles in the given figure. Question number 1, they have given us a figure, something like this. B, C, D, A. Now they have given us a figure and they're asking us to name the angles. Now earlier we have learned what angles are. Now we'll learn now how to name angles. Alright, we know that corners formed are all angles. Corners, all the corners are called angles. Now how do we name them? For example, this. I can simply name this as angle A. Okay? Or there's another way, or we can call it as angle. We will take two sides. The two sides where the angle is formed. Right? Two sides are forming this angle. So we can call this as angle DAB. Mind you, the angle should always be in the middle. The angle you want to depict should be in the middle. You can call it angle DAB or angle BAD. Same thing. DAB or BAD. Since angle A is in the middle, it is all the same. So this is one angle. The next is angle B or ABC or angle CBA. Just write angle ABC. Next is angle C or angle BCD or DCB. Alright? The final angle is angle D or angle ADC. We can call it angle ADC or we can even call it angle CDA as long as this D is in the center. All right? So when you say angle B, B is in the middle, C is in the middle, D is in the middle. All right? So these are angles. Now let's look at the next question. Question number 2. There's another figure given. Now let me quickly draw it for all of us. F, C, B, A, O. So this is the figure that is given to us. Now looking at this figure, we have to answer the question. Question number 2, it reads, in this given diagram, name the points, right? Name the points A in the interior of DOE. In the interior of DOE. See, we already discussed about the interior and exterior of angles. Now they're asking us in the interior of DOE, angle DOE, what points are given? So the first answer is inside the angle DOE, you can see one point, that is A. So this is the answer for the first question. Let's look at the next question. In the exterior of angle EOF. In the exterior of angle EOF. So let's look at this. EOF. This is the angle. If we draw it like this, it comes, you can see it like this. So we have to look at the exterior part. So the exterior part of this are, the points in the exterior are C, A, and even D. All right? Because this is the angle we are considering. So we can write A, C, and D. These are the points in the exterior of angle EOF. And finally on angle EOF. Finally on angle EOF. Points on angle EOF. That means EOF. We have to identify the points which are on EOF. So if you look at the figure, you can easily find out the points. See, the first point is E, the next point is B, the next point is O, and F. So there is your answer, E, B, O, F. These are the points lying on angle EOF, right? Now, let's quickly go to question number 3. Question number 3, draw rough diagrams of two angles such that they have a point in common, sorry. Question number 3A, a common point. So, we have to draw rough diagrams of two angles such that they have one point in common. So, the first angle, let's draw the first angle like this. Let's mark this A, B, and let this be O. Now this is the first angle, all right? Now we have to draw another angle. So sometimes we may be thinking we can do it like this, but they're asking us only for one common point. They're not asking us for one common ray. So we will have to draw another one like this. Mark this as C, mark this as D, your angle is formed. So you have two angles with one common point, all right? Let's look at B. 2 points in common, 2 points in common. So we can simply write like this. We are supposed to draw two angles, right? Yeah. So we can draw two angles now, and they want two common points. So we can mark this as A, B, C, and let this be O. Now we have two angles, but we need two common points. So we have one point B here, right? So we can put another point here, D. So we have now two common points, all right? The next is 3 points in common. So you simply have to keep increasing. You simply have to keep increasing three common points. So similarly, you draw this 1, 2, 3. You can mark this B, D, E, O with the same figure, A, C. All right? And the fourth one, 4 points. So you add one more point here, it comes to 4 points. And in the end, the last one, draw rough diagrams of two angles such that they have one ray in common. One ray. Now, your angles, the first angle will be this. Let's mark it B, A, O. One ray common. Now we can draw this ray as, take this as common ray and draw the other ray. So you have two angles with one common ray OP. All right? With this, we have come to the end of the exercise. We will continue with the rest of the chapter in the next class. So I hope you have learned something about, you have grasped a good idea about the topics that we have discussed today. So please keep practicing and see you in the next class.